Good morning everyone. Myself Mr. Awais Ahmed Hussaini, working as assistant professor in Mechanical Engineering Department at Sharda Institute of Technology College of Engineering Yadrao. So today we are going to discuss about introduction of the fluid mechanics. So what is exactly the fluid mechanics is? So it is defined as the branch of the engineering science which deals with the behavior of the fluid under consideration of the rest and in motion. The fluid mechanics may be divided into three parts. It may be fluid static, fluid kinematics, and fluid dynamics. So in fluid static, the study of the incompressible fluid under static consideration, it is called as a fluid static. And in case of the fluid kinematics, it deals with the velocity, acceleration, and pattern of the fluid flow, and by consideration the effect of forces and energy causing the velocity and acceleration are not to be under the consideration of the study. But in case of the fluid dynamics, it deals with the relation between velocity, acceleration of the fluid while it is in motion by consideration of the forces and energy responsible for them. Okay, so in this way the fluid mechanics are divided into three: the fluid static, fluid dynamics, and fluid kinematics. So there are so many applications in thermal engineering, aerospace engineering, automotive engineering, chemical engineering of the fluid mechanics. So one important term, that is aerodynamics, is also deal with the fluid dynamics or fluid kinematics. It deals with the flow of the gases. Especially you can take example of the air over the body, such as the aircraft, rocket, and automobiles with a low or high speeds. These are the some domains. Again, you just to take example of the gas dynamics, where that n number of the nozzles, diffusers are used. These are the some basic applications. Also you can take example of the hydraulics and pneumatics. These are also deals with the fluid mechanics. So as we know that the fluid are divided into so many types, like you can take example of ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, ideal fluid, then compressible fluid and incompressible fluid. So what exactly the Newtonian fluid? So the fluid which obeys the Newton's law of viscosity is called as a Newtonian fluid, and the fluid which do not obey the Newton's law of viscosity is called as a non-Newtonian fluid. In case of the plastic fluid, it is an ideal plastic, has a definite yield stress and a constant linear relation between the shear stress and the rate of the angular deformation. Just you can take example of the sewage sludge and drilling muds. These are the basic examples of the plastic fluids. When we talk about the ideal fluid, an ideal fluid is a one which it is incompressible and has a zero viscosity. Okay, so it is called as the ideal fluid. What is ideal fluid? The fluid which is initially incompressible and which have a zero viscosity. But keep in mind, there is no any such kind of the fluid is available. The water is a better example of this such kind of the particular fluid. So these are the basic fundamentals about the types of the fluids. And also there are so many types of the fluid, like thixographic and thyroscopic fluids. So there is a one concept, that is rheological diagram, in that there is a relation between velocity gradient and shear stress. In that we will get idea about the behavior of the different kind of the fluid, like ideal fluid, bilateral fluid, Newtonian, non-Newtonian, then ideal, plastic, real, and thixotropic substance. And we can study their behavior by changing their velocity gradient and how it will affect on the shear stress. That part is also included in the rheological diagram. So just I move towards the next part, the various properties of the fluid. So guys, there are so many properties of the fluids, like density, specific weight, specific gravity, viscosity, surface tension, specific volume, vapor pressure, capillarity. So we will discuss one by one. So density. So what exactly the density is? Density is nothing but the ratio of the mass per unit volume. So the SI unit of the density is kg per meter cube. So there are two types of the density. The first is a weight density, second one is a mass density. When we talk about the weight density, it is defined as the ratio of the weight per unit volume at a standard temperature and the pressure is called as a weight density. And when we talk about the mass density, it is simply the ratio of the mass per unit volume. The both unit for that particular density is kg per meter cube. Then next property is specific volume. Specific volume is just a reciprocal of the mass density. So it is a ratio of the volume to the mass. The SI unit is meter cube per kg. Then the important property of the fluid mechanics is specific gravity. So specific gravity is a ratio of the specific weight of the liquid to the specific weight of the standard fluid. I repeat once again, it is a ratio of specific gravity is a ratio of the specific weight of the liquid to the specific weight of the standard fluid. Okay, so there is no any SI unit, the unitless quantity is there. Okay, then next important property of the fluid mechanics is the viscosity. Viscosity is a property which deals with one law. The name of that law is Newton's law of the viscosity. So initially we will discuss what is exactly the Newton's law of viscosity. So Newton's law of viscosity states that the rate of the shear stress is directly proportional to the rate of the shear strain. Okay, so this is a Newton's law of the viscosity, and the definition of the viscosity is nothing but the resistance to flow between two adjacent layers is nothing but what? Viscosity. What is viscosity? Viscosity is nothing but resistance to flow between two substance or two layers is called as a viscosity. There are two types of the viscosity. The one is kinematic viscosity, second one is a dynamic viscosity. Dynamic viscosity is also called as absolute viscosity. Okay, after that the most important term is related with the different property of the fluid mechanics is the surface tension. Actually the surface tension is deal with the two forces, one is cohesive force, another one is adhesive force. So in case of the cohesive force, it is an intermolecular force of attraction between the same liquid. So it is called as a cohesion action or cohesive force. What is cohesive force? Cohesive force is the intermolecular force of attraction between the similar kind of the liquid. And when we talk about the adhesion, it is the intermolecular force of attraction between it is again intermolecular force of attraction, but at that in this particular case there are two different fluids are used. Okay, so simply it is caused by the force of cohesion at the free surface. It is called as the surface tension. So there are so many examples of the surface tension. The raindrop is always spherical in nature. The rise of sap in the tree. Bird can drink water from the pond. Breakup of liquid jets. And the SI unit of the surface tension is Newton per meter. Then the next property of the fluid mechanics is capillarity. So capillarity is a phenomena by which the liquid rise into thin glass tube above or the below is nothing but what? Capillarity. Capillarity simply states that the rise and fall of the liquid column in a glass tube is called as a capillarity. Okay, so these are the basic property, fundamental property of the fluid mechanics. Apart from that, the another property is compressibility. So it is a property by virtue of which the fluid undergo a change in the volume under the action of the external force is known as a compressibility, and it decreases with increase in the pressure of the fluid as the volume modulus increases with the increase of the pressure. So also it is designated by one symbol 1 upon K. Simply compressibility is a reciprocal of the bulk modulus, keep in mind, and the you can say it as a compressibility is a reciprocal of the bulk modulus. So another property is vapor pressure. So there are again certain assumptions and requirements are there. If the pressure on the liquid surface is lower than or equal to the surface or saturation pressure, then boiling takes place. Then vapor pressure is increases with the rise in the temperature. Mercury has a very low vapor pressure, hence it is used in the barometers. These are the basic certain assumptions are required while studying that vapor pressure. So vapor pressure or equilibrium vapor pressure is defined as the pressure exerted by the vapor in thermodynamic equilibrium with its condensed in a thermodynamic constraint, or you can say it as a phases of the given temperature and a closed system. So it is called as a vapor pressure. I repeat once again, vapor pressure also it can be designated by that equilibrium vapor pressure is defined as the pressure exerted by the vapor in thermodynamic equilibrium with its condensed phase at the time of the condense, the phase change takes place. So, and the system should be in not open, but it should be closed. These are the basic things. And one more important thing of the fluid mechanics is Pascal's law. So Pascal's law, it's nothing but you can say it as it is deals with the basic applications like hydraulic brake, hydraulic jack, and hydraulic cranes. So Pascal's law principle, in which mechanics, it deals with the fluid mechanics as well, in which the pressure changes at any point in a confined incompressible fluid is transmitted through the fluid such that the same change occurs everywhere. This is the basic principle of the Pascal's law. These are the important properties it is necessary to study in the fluid mechanics. Now the next is different types of the fluid. So here we will discuss different types of the fluid and their types. Already we discussed the different types of the fluid. So here we will discuss about the different types of the fluid flow. So there are so many types of the fluids. Type flows are available in the fluid mechanics, like steady and unsteady, laminar and turbulent, uniform and non-uniform, rotational and irrotational, one-dimensional, two-dimensional, and three-dimensional flow, compressible and incompressible flow. So we will discuss one by one. So here, in case of the steady flow, what is exactly the steady flow? The type of the flow in which the fluid characteristics like velocity, density, and pressure, etc., is not a change with time, is called as a steady flow. What is steady flow? The type of the flow in which the fluid characteristics like velocity, density, and pressure do not change with respect to time. But in case of the unsteady flow, the fluid characteristics like velocity, density, and pressure are changes with respect to time. When we talk about uniform and non-uniform flow, the type of the flow in which the velocity at a given time does not change with respect to the space is called as the uniform flow, and the type of the flow in which the velocity at a given time does change with respect to the space, it is called as a non-uniform flow. When we talk about the one-dimensional, two-dimensional, and three-dimensional flow, it is a type of the flow in which the flow parameters or fluid parameters like velocity is a function of the time in one space coordinator, is called as a one-dimensional flow. Also, in case of the two-dimensional flow, the fluid parameters like velocity is a function of the time in two space coordinator. And when we talk about the three-dimensional flow, the fluid parameters like velocity is a function of the time in the three space coordinator. Apart from that, in case of the rotational and irrotational flow, the flow is said to be rotational if the fluid particles, while moving in the direction of the flow about in its own mass, that is Cg, is called as a rotational flow. And if the fluid particles never rotate around its or along its own path or center of the mass, then it is not move, then it is called as a irrotational flow. When we talk about laminar and turbulent flow, the fluid when the fluid is moving, or when fluid particles are moving in the straight line without disturbing the other particles, then it is called as a laminar flow. The Reynolds number of the that particular laminar flow is less than 2000. If it is, the Reynolds number is lying between 2000 to 4000, it is a transient flow or middle flow, or when the Reynolds number is greater than 4000, then it is called as a turbulent flow. In case of the turbulent flow, the fluid particles while moving, they are crossed with each other. The movement is nothing but the zigzag manner. It is called as a that particular laminar and turbulent flow. And when we talk about last type, that is compressible and incompressible flow, in case of the compressible flow, it is a type of the flow in which the density of the fluid changes point to point. Okay, but in case of the incompressible flow, the density of a fluid changes point to point. So these are the different properties of the fluid. So guys, in this particular video we discussed what is fluid mechanics, what is fluid static, fluid kinematics, fluid dynamics. Also we discussed the different application of the fluid mechanics, along with the different types of the fluid, different properties of the fluid, and different types of the fluid flow. So this is all about some introductory part of the fluid mechanics. In next video we will discuss some different working principles and some equations of the fluid mechanics. Thank you.